Welcome back to my channel. Today we're going to be talking about the radius and interval of convergence of a power series. So this is a different thing than a geometric series where we're dealing with powers. We literally call this a power series. So the first thing that we want to talk about is what is a power series. Power series are in the form of the summation from n equals 0 to infinity of a sub n. So any sequence at all where we're also multiplying it by x minus c to the n power. A lot of our things are still the same, so c is our center. So c is a real number, which happens to be our center. X is x, like it's actually x. And a sub n is any series we've ever seen before, ever. Or maybe haven't seen before. So we have any series times this piece of x minus c. So, examples of power series. The first one we have is the summation from n equals 0 to infinity of x minus 1 divided by 3 to the n power. So the first thing that we're going to do is we're going to figure out what our center is. The big thing is our center is always x minus whatever value it is, so x minus. In this case, we have x minus 1, so our center is going to be 1. What do the terms look like? So if I plug in 1 for the first time, we get, or we plug in 0. So we plug in 0, x minus 1 divided by 3 to the 0 power, so it's going to all be 1. So our first term in this case is going to be 1 plus x minus 1 divided by 3 to the first power. So we have x minus 1 over 3 plus x minus 1 over 3 to the second power. But when I raise things to the second power, I can also put them as separately squared. So I could write it as x minus 1 squared divided by 3 squared, which may come in handy. And then it's going to keep going on like that forever. The only thing that's changing is that exponent. Another one that we have the summation from n equals 1 to infinity. I want 0, not 1. I think I keep saying 1. And it's going to be of negative 1 to the n times x plus 2 to the n divided by n factorial. So same thing, we're looking for our value of c. C is always going to be with x. Normally it's in the form of x minus c. So when we look at this, c has to be negative 2 because we have x minus our value. We're going to be plugging it in. I know that's going to be an alternating series because negative 1 to the n power. If I plug in 0, my first term is going to be positive because negative 1 to the 0 power is 1. So I have x plus 2 to the first power divided by 1, or 0 power divided by 0 factorial. 0 factorial is like something raised to the 0 power, so it's just going to be 1. So our first term is 1. When I raise it to the first, I change n to 1 every time. I'm going to have a negative instead. So we have x plus 2 to the first power divided by 1. And then it's alternating, so I know the next one's going to be positive. So we have x plus 2 squared divided by 2 factorial, which in this case would just be 2. And then we keep going on forever. So then we subtract, and it goes on. The last one that we're going to look at is the summation from n equals 0 to infinity of x to the n over n plus 1. Okay. Take a second, pause the video, and decide what you think the center is going to be and what our first few terms might look like. Okay, so in this case, since normally x minus something, we have x just by itself. So we don't have x plus anything, x minus anything. This means our c value is going to equal 0. Our first term is going to be when 0 is plugged in, so x to the 0 power divided by 1. So we have 1 plus x to the first power divided by 1 plus 1 plus x to the second power divided by 2 plus 1. And that happens forever. So a power series is realistically a series that's going to have this term x plus or minus c to a power that's going to be changing over time. So it's like if we took a Taylor polynomial and then made it into a summation. So our new question is, what's going to make this series converge? And when we talk about that, we have 3 different cases, which is why we're going to be talking about a radius. So we have 3 cases here. We converge only at the center of our function. So converges only at the center. What this means is that every term becomes 0. And we can say that because what we're plugging in something for x, and we are trying to decide what converges when we plug in a number for x. Well, if x is our center, then we are doing 0 a bunch of times. So when our radius is 0, because it converges at the center, or because it converges at our center, the radius that we are converging around is going to be 0. So our radius of convergence, how far we're away from the center and still converging, is 0. So big R for us is our center of convergence, or our radius of convergence. And C is our center, which is also the center of our convergence. So R equals 0 is the radius of convergence, and that just means how far away from the center do we still converge. Okay, so our next one is converges for x values within a finite distance from the center. This one is going to be our most common. And it's going to be our most common because it takes a little bit more than when it's a radius of 0 or the last one. So when we have a radius that is a finite distance away from our center, our radius is going to equal some number. We can say k, where k is a real number. One of the things that we need to know is that because it's a radius, it's kind of like a circle. So both sides of this from the center is going to be that distance away. So we want to remember that our interval is symmetric. About the center. So say our center is 3 and I have a radius of 5. I'm going to be 5 in both directions of 3. So 5 bigger than 3, 5 less than 3. And then our last one converges for all values of x. This means that our radius is infinite. R is going to equal infinity. We use the ratio test to help us with these convergence. So the test that we care about here is the ratio test. Although this tells us about the interval of convergence, this does not tell us anything about the endpoints, and we have to check those separately. So just like when we have to do anything else, this only tells us about everything up to that point, but it doesn't tell us about that very end point. And that's something that we're going to have to then plug in and solve for on our own. Every power series converges at its center. So at the very least, we're going to have that case number 1 where r is equal to 0, and we converge at the center. A series will converge absolutely when x minus c is less than r, and diverges when the absolute value of x minus c is bigger than r. So what this means is that this is inside of our interval and the other one is outside of our interval. If x minus c, the absolute value of it, is equal to r, the series can converge absolutely conditionally, or it'll diverge. And this is talking about the endpoints, and like I said, we have to test each endpoint. Okay, so we have the power series of the summation from n equals 0 to infinity of a sub n times x plus 4 converges conditionally at x equals 1. What can we say about r? So one of the things that we can say is we know what c is. So based off of this right here, I know we have x minus c is going to equal x plus 4. This means I can get rid of the x on both sides, so c has to equal negative 4. So my center is negative 4. This second piece here converges conditionally at x equals 1. We converge absolutely when we are inside of our interval. So because this converges conditionally, I know this has to be one of my endpoints. So what I can say is, if we were to look at this as a number line, right here would be negative 4, that's our center. Right here is 1, and this is where we converge conditionally. So if I look here, from negative 4 to 1, this distance is r. Well, I have 1 and I have negative 4, so if I do 1 minus negative 4, or 1 plus 4, this is going to equal 5, so I know r is equal to 5. The other thing that I can say, even though it doesn't ask us about it, is what the other endpoint is. So if I know r is equal to 5, and I know that my center is negative 4, 5 in this direction is going to be my other endpoint. So if I take 5 away from negative 4, we get negative 9. So negative 9 is my other endpoint. What I don't know is what's going on at this endpoint. So a lot of times when we look at these questions, they might be more of like a scavenger hunt of like, what do we know? What can we do? Things kind of like that.